January 21st, 1978. The Mediterranean Sea looks almost metallic, a stretch of gray so still it mirrors the anxiety of its time. The frigate USS Truxtun cuts through the calm, engines humming at 70% power, radar rotating in a mechanical heartbeat. For weeks, crew has patrolled the Horn of Africa, shadowing the tangled war between Ethiopia and Somalia. Routine boredom and salt-soaked fatigue define the hours. Then, at 13:00 hours, a dot appears on radar. At first, it's just noise, a signal flickering and vanishing inside electronic snow. Then a voice shouts, "Unidentified air contact, bearing 035. The radar operator watches the dot multiply. Altitude 30 meters, speed 100 knots. Direction, straight for the ship. Binoculars rise. Somewhere between the wind and the horizon, a tiny speck materializes, rippling like mirage, then resolving into shape. It's a helicopter, squat, angular, unmistakably foreign. Its color is steel and its insignia crimson. A red star, sharp as warning. Within the Truxtun's operations room, alarms blaze. Officers trade clipped commands. Battle stations manned. Weapon systems on standby. Outside, sailors squint upward at the swirl of rotors, blades slicing Mediterranean air. The helicopter circles them at barely 100 feet above the water. Turbulence breaks against waves, spraying salt over the deck. For 20 minutes, the Soviet aircraft holds its dance, round, deliberate, mathematical. Then, without gesture or message, it turns away and flies south, disappearing into low cloud. Official naval records classify it as one of several harassment incidents of unknown nature. But inside Soviet files uncovered decades later, the same encounter is listed as an operational test. The helicopter carried a new scientific device, a system able to measure neutron radiation escaping from nuclear warheads, even through metal hulls and seawater. A device that allowed Soviet eyes to see inside enemy ships without crossing their decks. Its name was Sovetnik, the advisor. And it marked the first time in history that nuclear arsenals were observed not by spies or satellites, but by science itself. To understand why a single helicopter circling a frigate could ripple through intelligence networks across the planet, we must step back to the architecture of fear that defined the Cold War. From 1946 until 1991, two superpowers, the United States and the Soviet Union, constructed a global ecosystem of competition. They spoke in rockets and megawatts, each trying to outsee and outthink the other. After Hiroshima and Nagasaki, the atom was reborn as political myth. In Washington and Moscow alike, scientists became priests of a new religion, deterrence. If both sides could destroy each other, neither would dare to try. But mutual assured destruction was never stable. Each year brought new technologies promising a faster first strike, a shorter reaction time, a clearer view of the enemy's intent. Satellites watched oceans, submarines listened to continental plates, radar mapped every movement of cloud and metal. The Earth became a network of permanent observation. In the early 70s, the United States formalized this aggression into language. James Schlesinger introduced a theory that a swift and precise attack on Soviet command infrastructure could decapitate any response. This was not madness. It was mathematics applied to war. The Kremlin responded with terror disguised as calm. Meetings inside the Politburo that winter recorded phrases like preemptive surveillance necessary for strategic security. If the West could conceal nuclear weapons anywhere, aboard ships not listed in treaty registries, then Moscow would be blind. Blindness meant death. What they needed was vision greater than treaties and than eyes. They needed a device that could make the atom speak. The greatest secret of the nuclear age was not the bomb itself. It was the silence surrounding it. Every warhead ever built, every reactor ever fueled, emits whispers of its own existence. Faint pulses, neutrinos, neutrons, the ghosts of fission. Most of the world never hears them. But in the mind of a physicist, those signals are louder than thunder. To the Soviet scientific establishment of the 1970s, understanding those invisible traces meant power. The Kurchatov Institute stood at the center of that understanding, a city of concrete and ideas rising on the outskirts of Moscow. Its laboratories were filled with mathematicians who had lived the shadow years of the atomic race, men and women who believed that numbers could protect their country as effectively as armor. Neutron detection was old in principle, yet new in ambition. Inside every plutonium sphere, atoms of plutonium-240 decay spontaneously, splitting into fragments and releasing a spray of neutrons. A single kilogram can emit millions per second. They are neutral, without electrical charge, and therefore capable of crossing steel and seawater without resistance. They carry no rumor of heat, no scent, no light. But what they do carry is signature, a rhythm that no other natural object can mimic. Across long years of reactor development and nuclear tests, physicists learned to listen to these rhythms with instruments known as helium-3 proportional counters. When a neutron strikes a helium atom, it transforms the gas for a fraction of a second, creating ions that register as a microcurrent, a tiny electrical pulse. Each pulse marking one neutron, one moment of truth. But detecting such pulses from air, above a moving ship, surrounded by cosmic radiation and solar noise, that was an impossible dream. The Sovetnik team made it reality. They designed nested detectors, helium tubes wrapped inside polyethylene moderators to slow incoming neutrons, coupled them to SCR amplifiers and logarithmic recorders so even minor fluctuations would paint visible lines on oscillographs. The apparatus became both sensor and camera, recording the atom's signature direct to film. Every flight was an experiment, every data strip a confession from matter itself. The first prototype was mounted on a naval Ka-25 helicopter in early 1977. Technicians built a control panel fitted to the co-pilot's seat, linking detector output to analog pressure meters and a round CRT screen. When the counter registered neutrons beyond background levels, the needle quivered, then rose. With every approach to test ships carrying training warheads, the needle rose again and again. The mechanical pulse was so consistent that operators often described it as heartbeat of the sea itself. Over that sea, the Soviet Union found its first new form of knowledge, not propaganda, not espionage, measurement. In the central archives of the Russian Navy now lie page after page of data tables from those tests: altitude, temperature, neutron count, distance, humidity. Each entry signed with the same remark: detection stable, probability 96%. Perfection was no longer an ideal. It was recorded in ink. Behind the technical details was a story of people. The scientists were not operators of fear. They were children of a century defined by fear. Many had survived siege and hunger and Stalin's purges, now building machines capable of preventing new catastrophe. In Design Office Number 6 of Vacuumash, engineers debated how to isolate cosmic interference from helium signals. Someone suggested layered shielding in borated plastic. Another proposed algorithmic filters using early microprocessors deployed in military navigation. Computers then were fragile, magnetic memory stored on reels, but Soviet programmers wired code by hand, entering syntax through switches. Those lines of code became Sovetnik's brain. If the count held steady for 3 seconds above threshold, the system logged a confirmed object. If the count rose and fell erratically, the algorithm ignored it as solar flare noise. Simple rules, profound accuracy. Physicists walked between chambers of plutonium and lead, calculating diffusion rates, drafting reports marked "secret." Navy pilots trained to read oscillographs mid-flight while managing altitude control. It was science and military merged into ritual. They were building a guardian of vision, a machine to look where human eye could not. By the end of 1977, the first operational flight occurred over controlled targets in Crimea. Reports mention wind gusts, magnetometer errors, but readings held perfect pattern. Officials approved funding for 3 units, codenamed Complex A1, A2, and A3. In April 1978, A1's readings were compared against ground-based spectrometers. Margin of error was less than 2%. Sovetnik passed its trial. Then came the real tests. Sea missions without announcement. The spring of 1978 felt brittle across naval lines. Outwardly, it was peace. Inwardly, it was a countdown. The Black Sea Fleet dispatched 2 aircraft fitted with the newly tested detection arrays. Their mission orders read simply, Environmental Radiation Survey. But inside sealed envelopes sat the true objective. Track and log U.S. naval movements in the Mediterranean and the Arabian Sea, confirm possible presence of tactical nuclear munitions. Each flight crew had undergone training not only in navigation but in physics. They learned to interpret pulse graphs, cross-reference range data with neutron flux. The readings were obscure language translated through discipline and repetition. Sovetnik's sensor arms functioned like ears pressed against the horizon. Every pulse arriving through helium-3 tubes was a sound of atomic life, a momentary confirmation that the sea still carried its deadly cargo. During those operations, pilots noticed something unexpected. Above certain ships, the background radiation seemed to pulsate, as though amplified by reflection off water. Engineers later confirmed that neutron scattering from the ocean surface created an echo effect, magnifying signals at specific angles. That phenomenon became instrumental to future calibration. Turn the helicopter 30 degrees, lower altitude by 10 meters, and the signal blooms like a hidden sunrise. By May, 4 American vessels had appeared in Sovetnik records. All carried warheads. All were detected. The successes were not celebrated with parades. They were whispered between researchers in dim corridors. Each scroll of data meant that the Soviet Union could practice verification that no nation had achieved before. In a world built on concealment, truth had become an advantage. Inside the Pentagon, reactions composed another story. Reports from the Naval Intelligence Command described unusual Soviet air patterns near fleet groups in the Mediterranean. Analysts compiled maps showing circles matching exactly the positions of nuclear storage compartments on U.S. ships. Coincidence was illogical. A classified conference convened at the National Security Agency in Fort Meade. Present, military, scientists, and aerospace contractors. Some dismissed the data as magnetic anomaly study. Others suspected groundbreaking radar. Then a quiet voice from the Defense Nuclear Agency suggested an outrageous alternative, that Soviet research into neutron fields could enable remote nuclear identification. The room fell silent. If true, treaty boundaries failed. Arms secrecy failed. Strategy itself failed. New orders issued. Reconfigure fleet routes. Reinforce reactor shielding. The Cold War was never about bullets. It was about belief. Every superpower depended on the illusion of certainty. In Washington, certainty meant control, knowing that American technology outmatched any rival. In Moscow, certainty meant resilience, trusting that no adversary could see its weakness. Sovetnik challenged both. KGB reports of 1979, declassified during the 1990s, show how its data wove through strategic debates. Each detected neutron count was correlated with satellite imagery, submarine acoustic records, and political analysis of NATO movements. The result? Confirmation that half of America's Atlantic fleet regularly carried nuclear armament without public acknowledgement. To the Soviet leadership, this proved the deceit of peace treaties. To scientists, it proved their device worked. Inside the American intelligence community, counterclaims spread. Some called Sovetnik fictional propaganda. Others privately labeled it probable. Speculative papers in the Science and Technology Directorate addressed the topic under the term neutron field reconnaissance. One memo dated March 1979 reads, "If functional, such system provides opponent with instantaneous knowledge of strategic asset deployment. Countermeasure research imperative." That sentence was a pivot point. Within months, the Pentagon commissioned additional neutron shielding research and ground detectors of its own. Secrecy no longer rested on steel, it rested on physics. By 1981, global tension again flamed. Soviet exercises codenamed Zapad-81 spanned the western frontier, simulating combined operations of Warsaw Pact forces. Hundreds of ships and 500,000 troops mobilized in unprecedented scale. Western observers interpreted the scale as precursor to invasion. The U.S. responded with its own large-scale NATO maneuvers, Ocean Safari and Able Archer. Between the two, a thread of Sovietnik flights continued across Black Sea training zones and Mediterranean lanes, quietly collecting data beneath radar noise. These missions served a dual purpose: technical validation and psychological message. Every American ship encountered felt watched by something they could not identify. It was science as deterrent, observation as pressure. Andropov, then head of the KGB, later General Secretary, called it a mirror we hold against our enemies. By the closing years of the 1980s, the world had shifted again. Propaganda banners faded. The language of science began to replace the language of threat. After decades of paranoia, rival laboratories started speaking to one another. American notes on nuclear verification circulated through channels the Kremlin did not immediately block. For the first time since the atomic race began, scientists sought to test, side by side, whether the Earth could be monitored for weapons without spies. In that new millennium of hope named Perestroika, Sovietnik stepped out from secrecy. The proposal came through academic routes rather than military. Representatives of the Natural Resources Defense Council in Washington had read fragments of Soviet papers on remote neutron detection and proposed a collaboration. Gorbachev's advisors approved with hesitation. It was peace by monitoring, peace through transparency. In July 1989, the chosen site was Yalta, on the Crimean coast, where 40 years earlier, leaders of the Second World War had met to redraw Europe. Now their descendants would redraw science. The Black Sea was mirror bright. Ships arrived under flags both red and blue. The Soviet Navy assigned the cruiser Slava as test platform, its missile bay housing dummy warheads with real plutonium cores. Two Ka-27 helicopters waited on deck, mounted with Sovietnik modules, the final generation combining improved helium-3 counters, digital storage, and laser range systems for distance precision. Nearby anchored the research vessel Ab Sharon, carrying American scientists from MIT, Stanford, and Maryland. Their apparatus was the contact gamma spectrometer, built to record direct radiation close to metal casings, but incapable of remote measurement. At precisely 0900 hours local time, the first rotor set broke the morning air. Sea mist swirled around the helicopter as it rose to 30 meters above the deck. Electronic recorders ticked, voltmeters climbed. Photographic film began spooling. Neutron flux spiked above expected background. At 80 meters, a second unit confirmed the reading. The data showed a distinct pulsation from the starboard missile bay, corresponding exactly with the known position of the test core. Operators smiled, then whispered. They had done it again. From air and distance, atoms had been seen. For American scientists present, the moment was revelation. One observer later wrote, "This technology turns invisible fear into numbers. It is as if nuclear weapons confess their presence by physics alone." Joint celebrations were modest: handshakes, a single shared photo, then a certificate signed in 2 languages confirming success. History records no speeches, only technical logs. When summarized that evening, the experiment proved a foundational truth for future arms control. Verification by measurement is stronger than verification by trust. Only months later, the world that made Sovietnik possible began to disintegrate. Economy crushed beneath inflation, ministries fragmented, laboratories lost funding. Across institutes of physics and defense, doors closed, researchers went unpaid, papers were burned for heat. The Kurchatov Institute itself survived only by transitioning toward civil nuclear energy. Its secret departments dissolved. Sovetnik's designers proposed new uses for their detector: border inspection vans capable of testing cargo for smuggled material, portable monitors for international airports. But without state support, dreams remained drawings. Prototype wiring was discarded. Helium-3 supplies reallocated to reactor safety systems. By 1991, the Union collapsed. Factories emptied, scientists emigrated. Sovetnik, a symbol of imagined clarity in a dark century, became just a file box in a basement. It was the fate of many Soviet wonders of physics, born from a nation that worshipped science, buried by its own chaos. Yet what Sovetnik, the advisor, had proven could not be unlearned. The data remained in archives, copied by future physicists of Rosatom and preserved in international libraries. Knowledge, once found, never entirely dies. Across the following decades, its echo continued. Technology migrated quietly into civilian work. Port security systems, container scanners, radiation monitoring portals across European borders. In the U.S., Los Alamos physicists revisited similar helium-3 detectors for use in the 1990s Radiation Detection and Interdiction Program. By the 2000s, CTBTO monitors employed multi-tube arrays descended directly from Sovetnik's design logic. Every count of neutrons passed through algorithms first imagined by Cold War scientists who wanted to make fear visible and therefore tame. The principle that once served confrontation now served protection. Atoms became the guardians of their own secrets. Scholars today analyze declassified KGB memoranda showing that Sovetnik's existence influenced negotiations of the INF Treaty and the later START I. Knowing that remote verification was possible, both powers accepted more open inspection protocols. Thus, a device born from mutual fear helped reduce that fear. Its scientific descendants continues in cosmic ray research, in neutron imaging for archaeology, in space missions measuring solar activity. The ghosts once hunted for war now map ancient ruins and planetary fields. Such is the metamorphosis of science. Tools of defense transform into tools of discovery. Time has shifted now, but the sea remains. Satellites track ships in orbits Sovetnik engineers could hardly imagine. Yet beneath our modern systems lies the same litany of numbers devised in those quiet Soviet labs: proton, neutron, pulse, verification, certainty. The alphabet of peace. In archives beneath the Black Sea Museum in Sevastopol rests one weathered sheet of data, penned by a technician whose name history forgot. It reads, range 80 meters, flux 3 × 10 to the 4th neutrons per second. Margin of error plus minus 5%. No signature. No timestamp. Just proof. Proof that even in an age of secrecy, truth found its voice through matter. Proof that a rotor in Mediterranean sky once listened to atoms and heard their confession. After all, it was a machine born from fear and transformed into knowledge. A symbol of how much humanity can achieve when observation replaces suspicion. Its rotors are silent now, its counters mothballed, but each port scanner that clicks quietly in airports around the world still speaks its language. Atoms do not lie. Physics does not take sides. And truth, once measured, remains. When the leaders of the United States and the Soviet Union met in Malta and declared the Cold War over, the world heard political closure. But beneath the waves it had already ended earlier. In neutron data over Yalta, when science proved understanding is stronger than fear. Sovetnik, the advisor, the eye that saw the atom and reminded us that peace is merely truth, finally understood.